Hello everyone, I hope you're safe and doing good. So today I'll be teaching you C++ language from the very beginner level. So if you don't know anything about the language, there's no need to worry because I'll be teaching you from the scratch, from the very basic level. So the question arises, why do we need a programming language? Now you need a programming language in the world of computers for the same reason you need a natural language like English or Hindi in everyday life to communicate with your friends and family. Now here's a catch. Like us human beings, computers don't understand Hindi or English. So this is exactly why we use a programming language. So what happens is we write some source code or a program. Now then that source code is translated by a translator which is known as compiler that translates the source code into binary language. Now binary language is a language that consists of zeros and ones which is understood by computer. So for example, you're communicating with a person who speaks French. Now here you'll require a translator who will translate your message into French and convey that particular message to the French person. So this is exactly what compiler does. Compiler translates your message into binary language, which is understood by computer, and then after understanding your message, computer gives you the output. So this is how exactly the whole thing works. Now let me explain you with an example. Suppose I'm saying hello to computer. I'm not writing any program here. I'm just explaining you what I just said. Suppose I wrote hello to the computer. Now this is what I have written in English. Now what the compiler will do is this hello will be converted into a language of binary language, which is 0 and 1. Let's suppose hello is converted to this. Now we cannot understand this 0 and 1, but the computer can. So now the computer will understand that you've said hello to the system. So now we know what is C++ and why do we use it. Now let's actually start using it. Now here I'm writing int main. What does this int main mean? Now this means that from line 1, from here, first block, our program is starting. Main indicates the start of the program. Start of the program. Now let's assume that here our program wasn't starting from line 1, it's starting from line 2. So now in this case also we'll say that our program starts from line 2 and not line 1 because int main represents the start of the program. Now we'll try to run this small code. Now let's compile and run. So as you can see that our task is complete, it has successfully executed. But there is nothing on the screen, right? It has just shown that process executed. But why isn't there anything? Because we haven't printed anything. So if you need to print anything, you just have to use cout statement. Let's suppose we are printing hello world. And we'll enclose our sentence or our word inside these double inverted commas. And we'll write endl. I'll explain this later why I'm writing endl. Let's first execute this thing. Right. So as you can see, there's an error. And why is there an error? Because the compiler doesn't know what cout is. So in order to tell the compiler what the cout is, we need to add two more statements. That is #include iostream. This is known as header file. Don't worry, I'll explain it to you. Using namespace std. Now if I try to run this program, successfully the program is compiled. Just a minute. Yeah. As you can see, hello world is printed. So with this, we've executed our very first C++ program. Now let's dive deeper into the structure of this program. The first line says #include iostream. Now it is a file. Let's add comments. It is a header file, also also known as preprocessor directive. Okay, now it is a file which has print functionality or the code of cout. The code of this particular statement. It is already defined in the file. That's why we use this file. If we don't use this file, we'll be getting an error like we did before. So this file is very important to add in each and every program, because in every program you'll be printing something. So whenever you need to print something, just always keep in mind to add its file also. So this is what is hashtag include IOString. Moving to the second line of code, it says using namespace std. Now I will not dive deeper into this. Let me just give you a basic idea. In C++, there are many namespaces. Suppose you have this namespace 1, namespace 2, namespace 3. And in each of these namespace, we have cout. Inside this namespace also we have cout. Inside this also we have cout. And here also we have cout. So here in C++ many namespaces are there which have cout functions in them. So we have to tell the compiler that we want to use the cout of suppose this particular namespace. Let me name this as std, or also known as standard. Always we use standard namespace. So using namespace std means that we are telling the compiler we want to use the cout which is present in the std namespace, right? So this is the concept of using namespace std. Okay, coming back to a program. After that you see that there's a semicolon. Now you need to add semicolon to end a particular statement. Suppose you write a sentence in English language, you always end it with a full stop. Whereas in C++ language, you don't use full stop to end a statement, you use semicolon. And it's very important to use. So first let's check what happens if we don't use a semicolon. Let's compile and run. Yeah, you see that there's an expected semicolon before int. So before int we have std, and before int we need to add a semicolon, right? So you need to end this statement. Now if we execute, again we are executing again. Yeah, we can see that our code is working just fine. So let me add a comment here. Semicolon is used to terminate the statement. Coming to the third block, this I've explained you, right? Start of the program. Int main represents the start of the program. Now why are we writing int here? Int is a data type. Int means integer. That means we are going to return an integer value. So we'll discuss more in detail about this data type int or integer later. Coming to the fourth line, as I've told, cout is used to print any type of statement. Let's see the use of the cout. Let's use it to print a number. Suppose 2. We're printing 2. Now let's compile our program. We can see that a program has successfully compiled. Yeah. Now let's run it. As you can see that hello world and 2 both are printed. So we can print an alphabet, we can print a digit, Now if we try to print 2 plus 2 inside us inside these double inverted commas, let's see what happens. 2 plus 2. So what do you think? Will it print 2 plus 2 or will it print 4? Let's check. Let's compile our program first. Here it has successfully compiled. Now let's run it. See, as you can see, the statement that the print statement that you used has printed 2 plus 2 instead of 4. So what we can conclude is that anything you put inside these inverted commas will be printed as it is, right? So if you want to sum two numbers, then we have a different procedure for that. That's a little bit of higher level that we'll see afterwards. So anything inside double inverted commas will be printed as it is. Now you might think, can we use single inverted commas? Yes, we can. Let's check. Let's print 4. Now let's compile and run. See, 4 has been printed. Okay, now, so why am I first compiling and then afterwards I'm running the program? So while you're in the beginning level of coding, you should first always execute your program, compile your program. So what a compiler does is it gives you the errors, right? The grammatical or the syntactical error. So it's always better, since you're a beginner, it's always better to compile your code first and then afterwards you can run it. Suppose let's add a syntax error. Suppose we are using this. No, we have already done this. Let's suppose remove this. Now we'll compile. See, it's giving you no match for operator this, because the single less than operator doesn't exist. It always comes in pair. So in this way you can begin your journey as a programmer. So now we have discussed almost everything. Okay, so the one thing that's left out is endl. Why are we using this endl? Suppose I'm removing this endl from here. Okay, and I'm just writing my statement that I want to print, and I'm terminating the cout statement. So now let's compile. We won't get any error. Yeah, the compilation is successful. Now let's run. See here, 2 and 4, 2 plus 2 and 4 are printed all together. So what endl does is, it prints the next statement in the next line, right? So let's add endl here. I'm removing endl from here. And in the next statement, I'm writing 8. I want to print 4 and 8 in different line, right? But if I don't add endl, they'll be printed all together. It won't be 4 and 8, it will be 48. So let's see. Yeah, the program has compiled successfully. Now let's run. Yeah, 4 and 8 are printed all together. So this is what endl does. It prints your next print statement in the next line. Now to make it more civil, let's add endl. Now we'll compile and run. Yeah, a 4 and 8 are printed in two separate lines. So here we have concluded with all the aspects here. Now we move on to the next topic, that is data types. There are different types of data types. So whenever you have to store any information or any data in the memory, you have to mention what type of data it is. Hence, data type. And also you have to tell how much memory it is going to take. So there are various different types of data types. Let's discuss them one by one. First, let's add our file, header file, or also known as preprocessor directive. Then using namespace std, start of a program, now let's take an example int a equals 5 and terminate our statement. So what does this mean? This means that a is a variable in memory which is of int type and it has value 5 in it. So how do we, just a minute. Okay. So this is the name of this block is a. So we can say that when we are writing int a, in our memory a block is created whose name is a, right? Its name is a and a value 5 is assigned to it. So this is how our this entire process works. So int is the data type, which means that it is an integer value. Here we can see that 5 is an integer value. That's why we are writing here int. A is a variable. Variable is a type of a container in which we store some value. For example, here we are storing value 5 in our container A, in our variable A. Okay, so this was about the data type, variable, and our constant. Now, how much memory does this int take? Int take 4 bytes of memory, which is also equal to 32 bits, since 1 byte equals to 8 bits. Okay, you can keep this in mind. This is an important thing which you'll use more in the further upcoming lectures. Okay, now we have another data type which is char. Okay, first we can print this A. Okay. So let's execute our program. Oh, sorry. Let's execute. We can see 5 is printed. Okay. Now let's remove this. Now we have another data type that is char. So char is always represented within double inverted commas or single inverted commas. It's your wish. So since we have created here another char, we can again say that a block of memory is a block is created in the memory whose name is char and the value assigned to it is small a. Okay, so this is how it works. Again, same, since it's a character, we have a character value here, and the name of the data type is char, which is character. Now let's put it over here by using comments. Okay. Now the third data type is bool, also known as boolean. Boolean has two values, either true or false. So we can say boolean equals to true. What does true means? Boolean, if there are only two possible values, either true or false. True means 1 and false means 0. So there is not much of a rocket science in this. It's very easy. Now let's try to execute this. Okay, so as we can see, there was nothing. So boolean cannot be stored in a variable. It's just a true or false value, right? Now moving on to the next data type, we have float. Now float we represent decimal point numbers, right? So let's take float t, right? So float we always use decimal point number, and again, if we say that when we use float, a block is created in the memory whose name is t and the value assigned to it is 1.2. Okay, so I forgot to tell you that our char takes 1 byte, which is equal to 8 bits. Our integer takes 4 byte, which is equal to 32 bits. And our boolean, since it's just 0 and 1 value, it takes 1 bit, right? The smallest one. For float, it takes 4 bytes, again, which is equal to 32 bits. Then the last we have is double. Double D equals to 1.23. It needs to be up to 2 decimal places. That's why it's known as double, right? So again, it's same. A block is created in the memory whose name is D and the value assigned to it is 1.23, right? So this is how you can interpret. So this was all about the data types that are used in our C++ language. Now we have data types, we have variables. We can operate on these variables by using different operators. So the next topic is operators in C++. We have different types of operators in C++. The first category of operators that we are going to learn is arithmetic operator. Okay. Arithmetic operators. Now what are these arithmetic operators? Basic operators that are used in our maths. First one is plus, the second one is minus, then we have multiplication, then we have division, and the last one is modulus. Now let's one by one use each of these. First let's define a variable a whose value is 2, another variable b whose value is 3. Now if we store the sum, if we want to suppose we want to do sum, int sum of a plus b, we'll get the addition. I'll explain it to you. First let me run this. Okay, now I'm compiling the program. It's compiled. Now let's run it. As you can see, the addition of a and b is printed. Now what happens here is that we are finding the sum. We're using our arithmetic operator plus between these two variables. Now this plus is the operator and a and b are the operands. And we have initialized another variable, that is sum. We have given the int value because the sum of these two, we want the sum of these two variables would be an integer, and we want an integer value. That's where we're defining it. We're using the data type int here, and semicolon to terminate our statement. Now let's suppose we wanted a number in decimal values. So I'm writing here 2 plus 2.4, and here I'm writing 3.1. Now we need to use here float. We need to define our variables as float and even the sum as float. Now let's compile this. Our program has compiled. successfully. Now we'll run this. As we can see, 5.5 is printed. This was about the int and float data type. Now if we want our answer up to 2 decimal values, we'll just add another data type that we learned about, that's double. Okay, now make it double. This also double. We'll make a sum also double. It's already double. Okay, now we'll compile. The program has compiled. Now let's run it. So as we can see, our answer is up to 2 decimal places. We have 5.53. Now this was about double. Coming on to our next operator, next arithmetic operator, that's minus. Let's take again a variable c. Let's name it as 4, and another variable a. Let's give it value as 1. Now if we want to find the difference between these two variables, we'll just again write the data type, subtract as the name of the variable, and we can do c minus a, and then we can see out our subtract. It is same as the plus operator. You just have to change the operator here. Operands can be anything of your choice. Yeah, so as we can see, we've got the answer is 3. 4 minus 1 is 3. Also, we can swap here. If you want to check if the compiler gives you a negative value or not. The compilation process is a little slow. Yeah, now we'll run it. And we can see we got minus 3 as the answer. So it also gives you a negative value. So this was about the minus operator or the subtraction operator. Now comes multiplication. Again, take two variables. Let's take p this time, and the value of p is 5. Another variable q, the value of q is 2. Okay. Now we want to multiply these two numbers. Again, we'll write the data type. We want an integer value, right? 5 into 2 gives an integer value. So now we'll write multiplication. Just write as multi, and then p into q. Now we can print our multi. Okay, so the program is compiling. We should get our output as 5 into 2, that is 10. Let's see what happens. Yes, we've got 10. Now if you think that if you want, you can also do one thing. You can omit this line, right, and just simply write here p into q if you want to make your program even more short. So you can just see out p into q. You can just print p into q instead of storing p into q in another variable, right? It's same thing. So let's check if it works or not. Compile. And then run. So we've got our answer as 10. So no matter what method you use to write the code, your answer will be same. So this was about the multiplication operator. Now coming on to the divide operator. Now you have to pay a little more attention here because this one's a little tricky. Let's suppose we have t as our first variable, and the value of t is 6. Now let's take another variable as r. Now the value of r is 2. Now we can write int div, which gives us as t slash r. Now if you see out this, what do you get? What will you get? You'll get 3. Now let's check if you get 3 or not. Let's compile. So yeah, it has compiled. Now let's run it. You've got 3 as the answer. Now where does this trick lie? Now if I change this value a little bit, if I make this as 4, now it is not completely divisible. You should get the answer in in points. So let's make it even more. If I write here 10 and if I write here 3, you should get 3.33 as the answer. Now let's check, what do you get? What exactly do you get? You won't get 3.33 as the answer, and I'll explain you why. You'll only get 3. Yeah. So why do you get 3 when the division of these two is 3.33? Because you wrote int here. That's why you're getting. You're writing here int. You're returning the division of this as an integer value. So instead of returning 3.33, it will just return an integer value, that is 3. Right? 3 is integer. And 3.33 comes under double. Or if you want just up to 1 decimal places, you use float. Right? So here you have to keep this concept in mind, because this type of questions are sometimes asked during interviews, also maybe during your exams or anything. They might give you the program and you have to give the output. Now suppose you see this code and you just divide this two and write 3.33 as the answer. It will be wrong, because we have integer here and the value will be an integer one. Now the question is, how exactly do we get this float value? Like I've told you before, in the addition operator, use float. Just write float equals to 10, float equals to float r equals to 3, and float div equals to t by r. Right? Okay. Now let's see out here div in a different line and see out this div in a different line. Also, let me write the add the code of double. If we write the same code in the double, float, we have r value as 3 and float div equals to t by r. Now if we see out div in a different line, because we're using ender, let's see what happens now. So we have got an error. Yeah, that's because we use the same variable name, right? Let's use here another variable as y, this as x, again change this to y, change this to x, and change this to div 1. See out div 1. Now again change this to tr, change this to, let's suppose, name it as rt, tr, and rt. Let's name this div as div 3, div 2, and this also as div 2. So now I think, yeah, everything should work fine. It's not. Okay, E is missing here. Again, let's compile. Okay, so the program has compiled. Now let's run it. So as you can see, you have got here 3, you've got here 3.333, you've got here also 3.333. So this is the concept of float, double, and int. You'll get the same answer. Okay, so let's again compile. And now let's run. Yeah, you'll get the same answer. So basically, if you want your division to give you the exact value, you need to either use float or div. You can use any of them. And if you want only the integer value of the division, that like the part before the decimal, then simply use int. Now our last one is modulus. So many of you might not know what modulus is, many of might you know. So let's take our C value as 10 and integer g as 5. Now if we try to find the mod of g, c and g, we'll get the remainder. We'll divide these two and we'll not output the division. In here we were giving the output, we were giving quotient as our output. Here we are giving remainder as our output. So we divide 5 twos are 10, so it will give remainder as 0. So the mod of these two numbers is 0. Whereas if we used division operator like in the previous case, we would get 2 as our answer. 5 twos are 10. So quotient here is our 2. So here you will output quotient and here you'll output remainder. Okay, let's output mod. So the program has compiled. Now let's run. So you can see we got 0 as our answer. Now let's take 6 here. Now let's see what happens. Compile the program and also run it. So you can see we've got 4 as our answer because our remainder is 4. 6 ones are 6 and 10 minus 6 will give you 4 as the remainder. Okay. So this is the difference between mod and division. We are finished with the first category of operators, that are the arithmetic operators. Now comes the next operator, that is assignment operator. So there's only one type of operator in this, that is equal to, single equal to. Now, how do we use this operator? This is very simple. Suppose I'm again taking an int value, int a, and I'm giving 7 to it. So what am I doing here? Here I'm assigning 7 value to variable a, which is of integer type, right? So this is what is an assignment operator. You're just assigning a value. You're assigning some type of value to an variable. Now just print this. So after printing this, you'll just get 7 and that's the end of your code. You've got 7. So there is nothing more in assignment operators. We only have one type of operator, that is equal to, and you're just assigning some value. So this was your second operator. Coming on to the third category of operator, these are relational operators. Now in relational operator, as the name suggests, we need to find some kind of relation between two different variables, right? The first one is equal to. Okay, I'll just write here how many types of operators there. The first one is equal to equal to. So last time we did was equal to, and this is double equal to. I'll tell you what the difference between them is. The next is this greater than sign. The third one is this less than sign. Then we have greater than equal to sign. Then we have less than equal to sign. And the last one is not equal to. So yeah, we've covered all types of relational operators. Now let's use them one by one. First one is double equal to, or we just simply say it equal to equal to. Let's suppose a variable s is equal to 3 and another variable r is equal to 4. So do you think the value of s and r is same? No, it's not. So this is what equal to means, that the value of both of the variables should be same. Now I'm going to write a little more code. You might not get it because you don't know what if-else statement is, but for now I'm just trying to explain you what double equal to is, right? So I'll explain this in the later video, right? So I'm writing one if statement. If s equal to r, what does it mean? If the value of s is exactly same as the value of r, then just print yes. Else, otherwise, if the value is not equal, then print no. From the code that we have written, we know that the statement that will be printed is no because the value is not equal. Now let's check whether it gives no or not. Compile the program and then run it. So as we can see, we've got no here. Now if we make this as 4, now our s is equal to r, right? Both the values are equal. Now we should get yes as our answer. So compile the program and run it. You're getting yes as your answer. Don't go this into the if and else statement. I'll explain this. Wait, I'm just trying to tell you what double equal to operator here is, right? So I hope you've understood what double equal to is, or equal to operator is. Coming on to the next operator, let's change the value as 7. Now this operator, as we all know, it is greater than operator. Again write a if statement. If s is greater than r, cout yes. Else cout no. Right. So here in this case, s is smaller than r because s is 4 and r is 7. So that means the statement that should be printed is no. Let's check. Run the program. No. So this is what this operator, greater than operator, tells you whether the the one variable is greater than the other variable or not. Here if I write 14, now it should be printed as yes. Compile it. And after compilation, run it. Yes is being printed. Now similarly, if we move on to the next operator, as simply if I write it as this. Now do you think that s is less than r? No, it is not. So it will print no. Yeah, no is printed. Now here if I make it as instead of 7, I make it as 17. Now our condition satisfies, right? So the output that we'll get is yes. Let's check. Let's run. Yes, we've got yes as an output. So this is the story of these two operators. Coming on to the next operator, it is very similar to this. Suppose, yeah, we have s as 14, r as 17. Now the operator that we're using is this one. Let's change this. Now, look at the condition. S greater than equal to r. This condition is false because s is neither greater than r and nor equal to r. So in this, if any of the two conditions satisfies, then we'll print yes. And if the condition doesn't satisfy, we'll print no. Here, the condition doesn't satisfy, so we'll get our answer as no. So let's compile it and now run it. Here we've got no as an answer. Now if I make changes in this value and make my s as greater than r. Just a minute. I didn't compile it. Yeah. So compilation is done. We've got yes as an answer because s is greater than r. Now if I make my r and s both same, then what do you think will print? It will print yes because I've put here two conditions. Either S is greater or S and R are equal. So you've got yes as an answer. Now similarly we have this operator. If I change this operator and change the value here, I make this as 1, I make this as 0. Now our condition says that our S should be small. Yes, our S is small. So we'll compile and the answer that we'll get is yes. We've got yes as an output. Now if I make them both same, again we'll get yes. Compile it and now run. You've got yes.